Hello everyone. Today I am going to explain about power series definition followed by ordinary point and singular points. About this I am going to explain now. Now power series. An infinite series of the form sigma n is equal to 0 to infinity Cn into x minus x naught whole to the power of n is equal to, if you expand the sigma, if you put n is equal to 0, the first term you will get as c naught plus c1 into x minus x naught plus c2 into x minus x naught whole square plus c3 into x minus x naught whole cube plus and so on you will get is called a power series in terms of x minus x naught, or is called a power series about x is equal to x naught. X naught is a point that may be 0 or that may be 1, that may be 2 or that may be 3 or that may be a, whatever the point about x is equal to a or about x is equal to 1, about x is equal to 2 or about x is equal to 3, x minus x naught. X naught is a point, given point. Infinite series. Here Cn is a constant. We can write instead of Cn An also. Sigma n, this is the power series. Sigma n is equal to 0 to infinity Cn into x minus x naught whole to the power of n is equal to. This is called power series in terms of x minus x naught, or about x is equal to x naught. About x is equal to x naught. In particular, if you take x naught value as 0, if you take x naught as 0, that means x naught is equal to 0, you will get sigma n is in particular. If you in particular means if you take x naught as 0, sigma n is equal to this equation becomes sigma n is equal to 0 to infinity Cn x to the power of n is equal to c naught plus c1x plus c2x square plus c3x cube plus and so on Cn x to the power of n up to in Cn x to the power of n you will get. This is the power series definition. In particular, about x is equal to x naught. About x is equal to x naught. If x naught is 0, that means about x is equal to 0. This will become the power series formula. Now, the next definition is analytic function. When will you say the function is analytic? When will you say the function is not analytic? A function f of x is defined on the interval containing the point x is equal to x naught is called analytic at x naught. The point they will give you x naught point may be 0 or maybe a, maybe 1 or maybe 2, maybe 3, whatever. X is equal to no, x is equal to 0 or about x is equal to 1 or about x is equal to 2 or about x is equal to a, like that they will ask. Is analytic at x is equal to at x naught if the Taylor series exists. Taylor series exists. What is the Taylor series? Sigma some function into x minus x naught. In more simply, if we want, I want to say means if it is a function is undefined, if it is undefined, then we say that it is not analytic. If it is defined, one function, whatever the function, if it is defined means it is analytic. When will you say it is defined or when will you say it is undefined? Now, some function, some value by 0 is equal to infinity. That means this function is undefined. Some 0 by some value or 2 by 3 or minus 2 by 3, some value. When will you say it is undefined? Some value by infinity, some value by 0 is equal to undefined. That means if you get a denominator as 0, then we say that it is undefined. Denominator 0 means you will get infinity. That's why it is undefined. Some number if you get 2 by x square or 2 by x cube or minus 2 by 5x square or 2 by 0 is equal to 2 by 0 is undefined. 0 by anything is 0 you will get. Like that if you get, that is defined. If it is undefined, then if the function is undefined, then it is not analytic. If the function is defined, that means some number either 0 or positive or negative, some number if you get, then it is defined. A function is defined, then we say that it is analytic. A function is undefined. Undefined means some value by 0 if you get, that is infinity. Infinity is undefined, therefore the function is undefined, therefore it is not analytic. This is about analytic. The next one is ordinary and singular points. Ordinary and singular points. Here, when will you say point is ordinary point? Very, very important. Remember, a point x is equal to x naught. X is equal to x naught. If x naught is 0, then we say that the point will become x is equal to 0. If x naught is equal to 1, then the point will become x is equal to 1. Whatever x naught based on the x naught. A point x is equal to x naught is called an ordinary point of the equation. Remember the equation, by heart this equation, very important. Y double dash plus p of x into y dash plus q of x into y. This is equation 1. Now a point, this equation y double dash plus p of x into y dash plus q of x into y is equal to 0 is, when will you say it is x is equal to x naught is an ordinary point? If both p of x and q of x are analytic at x is equal to x naught. At x is equal to, at that point x is equal to 0 or x is equal to a or x is equal to 1 or x is equal to 2, whatever the point, at x is equal to x naught, both p of x and q of x are defined, analytic. Both p of x and q of x are analytic at x is equal to x naught. Then we say that the point x is equal to x naught is ordinary point. When will you say it is analytic? When if p of x and q of x are two functions, means p of x and q of x are defined, then we say that it is analytic. If it is p of x and q of x are analytic, then it is an ordinary, then x is equal to x naught will become ordinary point. If it is not ordinary point, then it is called, if it is x is equal to x naught is not ordinary point, then it is called singular point. Remember, if it is not ordinary point, then it will become a then it is called a, x is equal to x naught is called a singular point. Once again I will repeat. A point x is equal to x naught of the differential equation in the form of y double dash plus p of x into y dash plus q of x into y is called an ordinary point if both p of x and q of x are analytic at x is equal to x naught. If it is not, when will you say it is analytic? If p of x and q of x are defined, then we say that it is analytic. If the point x is equal to x naught is not ordinary point, means it is a singular point. If it is a singular point. There are two types of, remember, there are two types of a singular point x is equal. There are two types of singular points. One is regular singular point, another one is irregular singular point. There are two types of singular points. One is regular singular point, another one is irregular singular point. What is regular singular? What is irregular singular? If a singular point, if I do one example, you can understand very well. If a singular point x is equal to x naught of the differential equation 1 is called regular singular point. If, when will you say a singular point is called a regular singular point? If x minus x naught into p of x, x minus x naught whole square into q of x are analytic. Now this is one formula. X minus x naught into p of x, remember, x minus x naught whole square into q of x are analytic at x is equal to x naught. Then only we say that it is a singular point is said to be a regular singular point if both x minus x naught into p of x, x minus x naught whole square into q of x are analytic at x is equal to x naught. If it is a analytic means these two are defined, then we say that it is analytic. These two are undefined, then we say that it is not analytic. If it is not a regular singular point, then it is called, if it is a singular point which is not regular singular point, then it is called irregular singular point. This is about ordinary point, singular point, regular and irregular point. Now we will do the first problem. What is the first problem? 2x square into d square y by dx square plus 7x into x plus 1 dy by dx minus 3y is equal to 0. Find the ordinary point or a regular singular point of the differential equation at x is equal to 0 is given. Now I have given the equation. I wrote once again the equation dividing the whole equation with 2x square. I have to convert the given equation in the form of y double dash plus p of x into y dash plus q of x into y. This is the standard form. This is the standard form equation 1. If it is given equation is in this form, well and fine. Otherwise we have to convert this in the given equation into this form. Now before some value, before d square y by dx square, some value is there, divided by 2x square. You will get a d square y by dx square plus a 7x into x plus 1 into dy by dx by 2x square minus 3 by 2x square into y is equal to 0. Now d square y by dx square plus 7 into x plus 1 by 2x into dy by dx minus 3 by 2x square into y is equal to 0. Now how much is p, how much is q? Now if you compare this equation with that equation, p of x is equal to, therefore identify p of x is equal to how much? 7 into x plus 1 by 2x is p of x. Q of x is equal to minus 3 by 2x square. Now this is in the form of y double dash plus p of x into y dash minus q of x into y is equal to, q of x into y is equal to 0. Therefore p of x is equal to, q of x is equal to this. Now at x is equal to 0, we have to check whether it is analytic at x is equal to 0 or not. At x is equal to 0, that means if you substitute 0, 7 into 0 plus 1 by 2 into 0, that is equal to 7 by 0 is equal to 7 by 0 is equal to infinity. Now if you take this one, at x is equal to 0 minus 3 by 2 into 0, that is equal to some number by 0 is infinity. Infinity means undefined. Infinity means undefined. This is also undefined. Therefore both p of x and q of x are undefined. Therefore p of x and q of x are not undefined, therefore not analytic at x is equal to 0. Not analytic at x is equal to 0. Not analytic means therefore x is equal to 0 is not an ordinary. X is equal to 0 is not an ordinary point. If it is not an ordinary point means therefore x is equal to 0 is a singular point. X is equal to 0 is a singular point. Now we have to find it is whether it is a, this singular point is a regular or irregular. To find this one, you have to check whether it is a regular or irregular. Now what is the formula for regular to check whether it is a x? I am writing the formula x naught into p of x. Now x minus x naught whole square into q of x. Now at x is equal to 0, that means x naught value is 0. X minus 0 into how much is our p of x? X naught is 0, x is equal to 0, that means x naught value is 0. At x is equal to 0, x naught value I substitute as 0. P of x is equal to how much? 7 into x plus 1 by 2x. Now x minus at x is equal to 0. X minus 0 whole square into q of x is minus 3 by 2x square. Now this x get cancelled. X square get cancelled. How much you'll get? 7x plus 1 by 2. Here how much you will get? Minus 3 by 2. Now at x is equal to 0. At x is equal to 0 means Again 7 into 0 at x is equal to 0 na. After cancelling we will put 0. 0 plus 1 by 2 is equal to 1 by 2. Here there is no point, that is equal to minus 3 by 2. That therefore at what we have got? Therefore at x is equal to 0, both x minus x naught into p of x and x minus x naught whole square into q of x are analytic. Why analytic? Both are defined. Some values you have got. You didn't get the infinity. That's why both are analytic. Both are analytic means therefore we can write x is equal to 0 is a regular analytic. Therefore x is equal to 0 is a regular singular point. Is a regular singular point. Second problem, show that x is equal to 0 is an ordinary point of x square minus 1 into y double dash plus x y dash minus y is equal to 0. But x is equal to 1 is a regular singular point. Now the given equation I wrote, I will convert this into the standard form. Therefore divide the whole equation with x square minus 1 y double dash plus x by x square minus 1 into y dash minus y means x square minus 1 is equal to 0. Now therefore how much is p of x? This is in the form of y double dash plus p of x into y dash minus q of x into y. P of x is equal to x by x square minus 1. Q of x is equal to 1 minus 1 by x square minus 1. P of x, Q of x we have find like this. Now at x is equal to 0, we will check whether x is equal to 0 is an ordinary point or not. X is equal to 0, if you substitute in P of x, 0 by 0 minus 1, that is equal to 0. 0 by 0 minus 1 is 0. If you substitute x is equal to 0 in this point, how much you will get? Minus 1 by 0 minus 1, that is equal to 1. Here 0 by anything is 0. Here minus 1 get cancelled, 1. Therefore both P of x and Q of x are defined. Defined means some value you have got, either 0 or minus 1 or plus 1 or some number or some fraction are defined. Therefore both P of x and Q of x are analytic at x is equal to 0. Both are analytic means therefore x is equal to 0 is an ordinary point. Ordinary point. Now another point we have to check. At x is equal to 1. At x is equal to 1. We will check another point because two questions are given. At x is equal to 0, show that x is equal to 0 is ordinary point of this one, but x is equal to 1 is a regular singular point. At x is equal to 1. Again I am checking. Now in P of x I will substitute x is equal to 1. In P of x is equal to, once again I will write x by x square minus 1. Q of x is equal to minus 1 by x square minus 1. At x is equal to 1. If I substitute x is equal to 1, 1 by 1 minus 1. 1 minus 1, 1 by 0 is equal to infinity. Here if I substitute x is equal to 1, minus 1 by 1 minus 1, that is equal to minus 1 by 0 is equal to infinity. That means at x is equal to 1, both P of x and Q of x are undefined. What is the meaning of that? Undefined means not analytic. We will write. Therefore, both P of x and Q of x are undefined at x is equal to 1. Therefore, both p of x and q of x are not analytic at x is equal to 1. Not analytic means therefore x is equal to 1 is a singular point. X is equal at x is equal to 1, both are not analytic means it is not ordinary point. It is not ordinary point means it is a singular point. X is equal to 1 is a singular point. Now we have to find whether it is a regular or irregular. What is the formula? X minus x naught into p of x, x minus x naught whole square into q of x. We will check. At x is equal to 1, our point is x is equal to 1. X minus our point x naught is 1 into p of x. How much is our p of x? X by x square minus 1. Now x minus 1 whole square into q of x is, how much is q of x? Minus 1 by x square minus 1. X minus 1 into x by x plus 1 into x minus 1. X square minus 1 we can write as like that. Now x square x minus 1 whole square. Like that. Now at x is equal to 1, we will substitute x is equal to 1. 1 by 1 plus 1 is 2. Now here x minus 1, x is equal to 1. X minus 1 whole square into minus 1 by x plus 1 into x minus 1. X plus 1 will get. Now if you substitute 1 minus 1 by 1 plus 1. 1 minus 1 is 0. 0 by 2 is equal to 0. It is defined. This is also 0 means defined. Some number or 0 or negative or positive, whatever. Therefore, both p of x and q of x, both p of x and q of x are defined. X minus x naught, ikkada x minus x naught whole square into q of defined at x is equal to 1. Therefore, x minus x naught into p of x and x minus x naught whole square into q of x are analytic at x is equal to 1. Analytic at x is equal to 1 means therefore x is equal to 1 is a regular singular point. Thank you very much.